circular coil, deflection magnetometer method. Today the aim of our experiment is to study the variation of magnetic flux along the axis of a circular coil using a deflection magnetometer, and also we want to calculate the horizontal component of Earth's magnetic field at the given place. We are provided with a circular coil apparatus and a deflection magnetometer. Coming to the circular coil apparatus to determine the or study the variation of magnetic flux along the circular coil and also for the determination of BH. We are provided with a circular coil apparatus, and the circular coil apparatus consists of a circular coil of thin insulated wire of about 20 or 50 turns, and this wire is wound over a wooden frame, and this particular frame is fixed vertically on a horizontal base, and there is a horizontal platform at the center of the circular coil, and we can place a compass box at the center of the circular coil. When we place the compass box at the center of the circular coil, the magnetic needle is at the center of the circular coil that coincides with the center of the circular coil. The center of the compass box coincides with the center of the circular coil. Now coming to the theory, there exists the horizontal magnetic field at every point. Say BH is the horizontal component of Earth's magnetic field that also exists at the center of the circular coil. Now when a current I is passing through the circular coil is kept initially in the north-south direction. So a magnetic field B is produced, and that magnetic field is perpendicular to the plane of the coil. That means it is in the east-west direction. So these two fields B and BH are acting mutually perpendicular. So we can apply the tangent law. Then we are having the tangent law B is equal to BH tan theta can be applied. Now from that BH is a constant. So B is proportional to tan theta. So if you are changing the distance at different points of the circular coil on the axial line, at every point the magnetic field is proportional to the deflection produced, and that we are studying in the first part. Now coming to the adjustment of the circular coil apparatus. Now we are having a power supply, so that is connected to a key and a rheostat and ammeter, and it is connected. The circular coil is included with the help of a commutator. The commutator is used to reverse the current in the circular coil. For example, initially let the two opposite keys, one here and one here, is closed, here and here. You can see that the current is flowing like this. After coming to this particular point, it reaches here. Then it is flowing in the anti-clockwise direction. You can see it reaches here, then going to the other side and completing the circuit. So the current is in the anti-clockwise direction. Now when the commutator is reversed, we are putting the key, this one, say 2 and 3 here, or 2 and 4, this one and this one. Then the current reaches at this particular point here, then it flows to here, then it is coming in this way, then the current is in the clockwise direction and it reaches here and at this point, and the circuit is completed. So we can change the direction of current either clockwise or anti-clockwise with the help of the commutator, and that is the use of the commutator. Now initially the current through the circuit with the help of the rheostat is adjusted to get a deflection nearly about 60 degree. Then the current is noted. Then we are getting two deflections in the deflection magnetometer. Then the current is reversed. Then also we are getting two more readings. Now we place the compass box at a certain distance, say 6 centimeter on the eastern side. The coil is now in the north-south direction. Now we can place the compass box in the eastern side at a distance of 6 centimeter. For the same current, we are determining the deflections. We obtain the deflections 1 and 2. Commutator is reversed. We are getting the deflections 3 and 4. Then the compass box is placed on the other side, that is the western side, at the same distance 6 centimeter. Then for the same current I, we are obtaining the distance deflections 5 and 6. Commutator is reversed. We obtain the deflections 7 and 8. Then we obtain 8 deflections. The mean deflection theta is calculated, and from that tan theta is calculated. Now we change the distance to another value, say 8 centimeter, 10 centimeter, 12 centimeter, etc. And each time we determine or we obtain all the 8 deflections, 4 in one side, eastern side, and 4 in the other side, western side. The mean is calculated and tan theta is calculated. Now you can plot a graph between the distance and the tan theta value, and that graph gives the study of the variation of magnetic flux density in a circular coil apparatus. So that is the nature of the graph that we are supposed to get, the distance tan theta graph. Now this is the tabular column for the observation. We are having different distances, the deflections in the compass box 1, 2, 3, 4 when it is placed in the eastern side, mean theta and tan theta, and the deflections when it is placed in the western side, 4 readings are there. We are taking the mean theta and tan theta, and it is repeating for different distances, say 6, 8, 10, 12, 14, etc. Now coming to the second part, that is the calculation of BH. Now the magnetic field produced by a circular coil apparatus is given by the formula B is equal to mu 0 n a square I divided by 2 a square plus x square raised to 3 by 2, where I is the current flowing through the circular coil, A is the radius of the circular coil, and x is the distance. Earlier we used the distance of say 6 centimeter, 8 centimeter, etc. That is the distance from the center of the coil to the center of the compass box. So that is the value of B, but this B is equal to BH tan theta. Now from that we can calculate the value of BH. Now BH is equal to mu 0 n a square I divided by 2 a square plus x square raised to 3 by 2 tan theta, where n is the number of turns of the coil. We are using a coil having 20 or 30 turns. Then from that, knowing the values here, to proceed, we are adjusting the circular coil. Initial adjustments are done. For that, we want to keep the circular coil in the north-south direction. So two adjustments are there. Initially, the compass box is rotated so that the 1990 line of the compass box is parallel with the vertical plane of the coil. The 1990 readings of the compass box is parallel with the vertical plane of the compass coil, and then the whole apparatus is rotated so that the aluminum pointer reads 0, 0. When we perform these two adjustments, we can see that the circular coil apparatus is kept in the north-south direction. So that is adjustment for the circular coil. So as we mentioned, we are sending a particular current, say 0.2 or 0.3 ampere current, and the distance is kept fixed for a certain distance, 6 centimeter. Then we are obtaining the deflections. So for a particular value of distance and for a particular value of current, we obtain 8 deflections. We calculated the mean theta and tan theta, and from that we can calculate the value of BH. Now in order to repeat the experiment, either we can change the value of x, but usually we are keeping x as a constant. If we keep x as a constant, then we can determine I by tan theta, because all other terms are constant. So for a different value of current, deflection is changing. So keeping the distance a constant, we change the current and then note the deflections and find the value of I by tan theta. Then this is the tabular column for that. The current we can change, distance also we can change, or we can keep the distance as a constant. We are obtaining the deflections both in the eastern side and western side. Then mean value of theta and BH is calculated, and so we obtain the result BH. Now this is the experimental setup for the circular coil apparatus. We are provided with a source. From the positive of the battery, it is connected to the positive of the ammeter. Then from the negative of the ammeter is connected to a rheostat, and from the rheostat it is connected to the negative of the battery through a commutator. We are using a commutator here, and we include the circular coil apparatus using the commutator. The other two terminals of the commutator is connected to the circular coil apparatus. Now to start with, we have to arrange the circular coil along the north-south direction. The circular coil is should be arranged along the north-south direction. Now for that, there are two arrangements are there. The compass box, which is placed at the center of the circular coil. Now we have to find out the 90 and 90 line of the compass box. Place the 90 line just below the circular coil, that means in the plane of the circular coil. Now 190 is here, and the other 90 is here. The 90 line is in the plane of the circular coil. Then you can rotate the whole apparatus you can rotate. The whole apparatus you can rotate. The circular coil apparatus you can rotate, so that the aluminum pointer should read a reading of 0, 0. So the second adjustment is, the first adjustment is rotate the compass box alone, so that the aluminum pointer compass box rotates alone, so that 1990 line is just below the plane of the coil. And the second adjustment is the whole apparatus is rotated, so that the aluminum pointer reads 0, 0. Now you can see the coil is along the magnetic meridian or north-south direction. Now with the help of the commutator, we can pass a certain current through the circuit, and we can adjust the rheostat. Here the rheostat is adjusted, so that say initially a current of 0.4 ampere is flowing through the circuit, nearly 0.4. We can adjust a current of 0.4. Now it depends on the coil, the number of turns of the coil, etc. So the current is adjusted such that the initial reading is nearly about 60 degree. So here I am getting a reading of 57 at one end and 57 at the other end. The current is adjusted such that the initial reading is about 60. So here for a current of 0.4, I am getting a reading of 57 and 57. Now with the help of the commutator, we are reversing the current. The current through the circuit is reversed. Again, the aluminum pointer reads 2 more readings in the other 2 quadrants. Again I am getting a reading of 55 and 56. So for a particular current 0.4, I got 4 readings, 58, 57, 56 and 55. Now we are repeating the experiment for the same current. For the same current, we want to change the distance. For that, we are using another support, a vertical support we are using, and we are placing the compass box on that vertical support. The compass box is shifted, so that again the aluminum pointer reading is 0, 0 here. Now the distance between the center of the compass box and the center of the coil that we can measure here, that is 6 centimeter. Now the compass box, the center of the compass box is at a distance of 6 centimeter that I measured with the help of a scale here from the center of the coil. Again the current is passed, so we can note the current is same as 0.4 ampere. The readings are changed. Here I am getting a reading of 44 and another reading again 44. Now we are reversing it, then we are getting the third and fourth reading. Now we are again changing the distance. Now the distance is changed to a distance of say 8 centimeter. Now the distance is changed to 8 centimeter. Then it is changed to a distance of 12 centimeter. Again I am taking the reading. You have to take all the 4 readings. Now it is changed to a distance of 14 centimeter. The distance is again moved. Now for a distance of 16 centimeter and for a distance of 18 centimeter. Now this is the eastern side. In the eastern side, 4 distances 6, 8, 10, 12, 14, 16, 18. For that distances, we are taking all the 4 readings. Commutator one side and commutator reversed. So that is 4 readings in eastern side for different distances. Now we are taking the readings on the other side, that is the western side. For that, the compass box is placed on the western side of the coil, initially at a distance of 6 centimeter. We start with the 6 centimeter. So the distance between the center of the compass box and the coil is 6 centimeter. We can take the readings, 2 readings. Commutator is reversed, 2 more readings. Now it is moved to a distance of 8 centimeter. We are taking the readings, 10 centimeter readings. We are taking 12 centimeter, 14 centimeter, 16 centimeter and 18 centimeter. So that is the readings for the different distances in the western side. So we completed both the 2 sides, and using that readings for each distance we are having 8 readings. We can calculate the mean theta, and then we can calculate the tan theta value, and that is our observations. Now for the second part, that is for the determination of BH, we are repeating the experiment for different currents and different distances. So initially we fix the distance x the distance between the center of the coil and center of the compass box, that is A. Initially I fix the distance say 6 centimeter. So x is 6 centimeter. Now we are varying the current. Now we can vary the current with the help of the rheostat. So initially we fix the current say 0.2 ampere. So I in the circuit is 0.2. Now as in the earlier case, the compass box is arranged. We are getting two readings here. Here I am getting a reading of 32 and 32. Then we can reverse the current in the circuit. Then again we are getting two more readings, that is again 32 and 32. So I obtained 4 readings, that is in one of the side, that is for a current of 0.2 and the distance is 6 centimeter or 0.06 meter. Now we are varying the current to another value, say let the current is changed, say another value say 0.3, the current is changed to another value 0.3. Then again I am taking the readings. Here I am getting a reading of say 42 I got, 43 I am getting here. We are reversing the current is reversed. Again the current is 0.3. So the readings are again 42 and 42. So I got 4 readings. Now we are repeating for another current say 0.4 or 0.5 etc. on the same side, eastern side. Now as in the earlier case, we are keeping the compass box on the other side at the same distance 6 centimeter, and for the same values of the current, say initially 0.2 we are taking the readings. We are getting 2 readings, commutator reverse 2 more readings. So we obtain 4 readings. So totally for a current of 0.2 we got 8 readings. 8 readings we obtain. We can find the mean of that 8 readings. Then we can calculate the value of tan theta. Then we can calculate the value of I by tan theta. I is 0.2 here and mean value of tan theta is calculated. I by tan theta is calculated. Now it is changed to another distance. The current is changed to a value of 0.3. For the current 0.3 also we got 4 more readings. So totally 8 readings. Again for a current of 0.4 we are repeating. So that means we are repeating it for different currents and we are finding the value of I by tan theta. From that we can determine the value of BH. Now coming to a sample observation to study the variation of magnetic flux. We are keeping the distance. Initially the compass box is placed at the center of the coil, so the distance is 0. Then we obtain the deflections, say 4 deflections. Now this value will be the same because it is at the same distance, 0 distance. Then it is kept on one side, that is in the eastern side at a distance of 6 centimeter. I got 4 readings and the mean is calculated, mean tan theta is calculated. So that is in the eastern side. Similarly, the compass box is kept at a distance of 6 centimeter on the western side. There also I got 4 readings and mean theta is calculated. So we are having the tan theta value both in either side, eastern side and western side. Then it is repeated for another distance, say 8 centimeter. Here it is repeated for a distance of 9, say 12, 15, 18 with a change of difference of 3 centimeter each. So in both sides tan theta value is calculated, eastern side and western side. Then we plotted a graph with the tan theta value along the y axis and the distance. Here the distance, eastern side 6, 9, 12, 15, 18 centimeter. Similarly western side 6, 9 and the corresponding value of tan theta in the western side and eastern side. So a graph is plotted and that is the study of the variation of magnetic field. Then for the determination of BH, now here we are changing the current and the distance is kept a constant 6 centimeter. So the current is 0.2, 0.26, 0.3, 0.4 etc. So for a current of 0.2, when the compass box is placed in one side, that is eastern side, we obtain the first 4 deflections as 32, 32, 32 and 32. And when for the same current and for the same distance, when it is placed on the other side, western side, the deflections are 32, 32, 30, 31. So the mean deflection is calculated and from that the tan theta is calculated. This is tan theta value and I by tan theta is calculated, 0.2 divided by tan of theta, 0.61358, that is calculated, 0.3250 we obtain. Now it is repeated for the same distance but another current 0.26, the deflections are noted and I by tan theta is calculated. Again it is repeated for 0.3 and 0.4 and each time we obtain I by tan theta and mean I by tan theta is calculated 0.3184. And for the given circular coil apparatus, the number of turns is noted, that is 30, and the circumference of the coil is noted with the help of a string, that is 70.5 centimeter I obtained. So the radius of the coil A is equal to circumference divided by 2 pi, that is 11.226 centimeter or 0.1122 meter. Now the distance xb used is 0.06 meter, 0.06 meter. So we can calculate the value of b or bh, mu 0 n 30, a that is 0.1126, the square, I by tan theta we are substituting, 2a square plus x square, x is 0.06. So it is calculated and we obtain a value of 0.365 into 10 to the power of minus 4 Tesla. So that is our result. The horizontal component of Earth's magnetic field at the given place is 0.365 into 10 to the power of minus 4 Tesla we obtain.